And so we come to video number 4 in our Creating Datasets series of videos. Here we come to look at the data that we need to put into our dataset to make it understandable, reproducible, reusable, the explanation data. We've already looked at the background, explaining why we do data sets. We've looked at how to get our minds around our data relative to making a data set. And we've looked at what to do with our data, the information data, the actual data we collected. And now we come to look at this explanation data, the extra data that's needed. When we talk about explanation data, we're talking about data that's about what I did, what I used, what I asked. It's answering the question how I got the data that I've already presented. So first up, we need some kind of contents. We need to tell people what's in our data set. So in a large data set with multiple files, we might need a first file, a document called something like contents of dataset. And here we'll give the background information of authors, links to publications, even a whole list of publications. Maybe it's a report and we've done all sorts of journal articles that go with it. But also it will have information which enables people to navigate the data set, which enables them to look at these 10 or 15 files and decide which one to open, in which order they're going to look at them. Or when they come back, enables them to find the file that they're thinking of, that they want to look at for the information that they're looking for. But each file also needs some kind of first sheet, which gives background information, authors, who did what, perhaps different people did different parts. That gives information with links, with other publications that are relevant, and which shows how this data set fits with other publications, and also which gives any specific information maybe about this data set. And then it also enables people to navigate the workbook. So it'll have a list of contents which show what's in the workbook and where to find it, sort of how many sheets along it is, which gives people, you know, when you have a workbook, it's got the tab has a very short little title on the bottom. So here on this sheet, we'll also include a longer explanation of exactly what is in that sheet with that small little designation, that small little tab title. So first up, what is the data that we need to make our experimental data meaningful? First things first, an experimental plan. So some of our experimental plan will have been explained, enumerated in the article, in the publication. But here we'll have a lot more information of exact times, days, amounts, rates, conditions, things that there's not enough space for in the publication. And it will be laid out in a way that's much easier to follow. So we need to come up with our experimental plan. And here, of course, you must remember it's not just the plan that you had to start with, but also the actual what you did. And you may have to put both of these in different ways. Then we also need to explain our equipment and setup. Again, some of this will be in the publication, but often not all. I mean, for example, you may say that you used a 5-liter reactor. Well, was it a 5-liter reactor like this, or a 5-liter reactor like this? Oh, you can't really see me. Was it, you know, 500 centimeters tall and a tiny, thin, narrow reactor, or was it a big fat reactor, not very high? So that sort of information often comes in this background situation where you say exactly what equipment you used, and give dimensions, positioning, how the instrumentation functioned relative to the reactors, and so on. So you give the details of your equipment and the setup and how it functioned together. And then methods and protocols. So some of this again may be in the publication, but here you give your full methods. If you take them out of the CIBA methods manual, you just reference it. Model numbers of instruments, temperatures, times, rotation speeds, all sorts of things that go into your protocol that won't be in the publication. And you make sure that if someone wants to repeat your experiment, they've got all the information there to do it exactly the same way that you did it. And then analyses. Obviously, our publications are very seldom just what we did and what answer we got, but what does the answer mean? And how did we analyze it? Let's have a look. So first up, standard curves. Very often, as I've said before, you get your raw data is not the data that you're going to use. It's an optical density, when what you're really going to talk about is the concentration. So you need to this depends on whether you've used your absolutely raw data, but it is absolutely necessary if you include your raw data. You must show how you got from your raw data to your usable data, and for that you need your standard curve. And including this absolute raw data and your standard curves, it shows something about how you feel about your data. It shows that you're confident that your data is good data. It shows that you're sure that you've done the right thing. So you have a sheet at the back of your workbook, which gives your standard curves, shows how you got them, and has the constants which you're going to use for your calculations, so that you're not inputting the constants in another place, that they're used from this sheet. Then calculations. Just so little word of warning, make sure you understand the statistics you're using. If you're not sure, ask your supervisor to explain, or go and do a short stats course. There's lots of useful little courses out there. But your formulae for the calculations can go on the same sheet as the calculations if they're quite contained. But when you have very complex calculations, maybe formulae that have to be explained, you can put your formulae on a separate sheet, and your formulae and your references and your explanations on a separate sheet, and then you can have your calculated data on yet another sheet, a third sheet. Notice that quite often you use a lot of constants in your calculations, and those should always be put on a separate sheet right at the back of your workbook, where nobody needs to look at it unless they want to. And then you use those constants in your calculations. And it means that if you need to change your constants, you can do so without changing every sheet on your workbook. And then make sure you cross-reference to the calculated data sheets from the formulae, and make sure that you cross-reference again to graphs, any graphs that you may have on different sheets. Graphs. Graphs are one of the chief ways that we analyze our data, because it visually shows what we're seeing in the numbers. But just a caution to consider the form of your graph carefully. Not all types of graph are helpful for all types of data. If you're not sure, try several different kinds of graph or chart and think about what it's telling you by the form in which it is. So for example, if you have discrete dots and you don't join them up, it looks as if they're in the same series but quite separate in some way. If you join them up, it shows that you think that something was happening between those two dots that moved your mixture from one to the next. That sort of thing, you have to ask yourself, what is this graph showing? What is this saying that's not there in words? And then make sure you remember things like error bars, work out what you're going to do with outliers and how you're going to demonstrate that. And then use your colors and shapes and types of line wisely. So remember that some people are colorblind. Less and less frequently today people look at things in black and white, but that also needs to still be acknowledged. But remember that that not everybody can see the difference between green and blue, or between red and green often. So you can look that up to make sure that you've shown it in a form that everybody will be able to read. Then methodologies. You need to explain how you did what you did. Things like de-identification and statistical methods. Always explain what you did and why you did it in that way. Models. Our simulations. Make your code comprehensible and academic. We're not hackers, we're academics. So demonstrate your logic. Give yourself headings. Make comments that show how you're moving from one thing to the next. Especially note conversions from one type of unit to another, and specify your constants. Assign a symbol to it and put the constant in there separately, so it's not just a number that looks as if you pulled it out of a hat. Always be showing exactly what you've done and why you've done it, so that the person who comes after you can follow your code. And then acknowledge sources. As I said, we're not hackers, we're academics, and so we state the platform that we've used. Reference, if you've taken plug-in passages, say where you got that. Give the source of reused code, and where possible, if there's a seminal article that links back to the sort of first place that this piece of code was used or this idea was used, try and include that article if you can. Then reviews. Reviews are another kind of data. and you need to show how and where you collected your review data. This will depend on the type of review. There are several different types of review. For example, you may have extracted data from other studies and collated it. Often in that case, you have to do calculations so that it's all in the same units or something like that. Then you may collect studies and compare the studies with each other. Or you can collect the types of study and compare the metadata. So for example, down in the chart on this slide, we've looked at different countries and the tons of paper that were produced in them, and then of course we have to give where we got the information, and we have to make sure that it all is in the same units and the same year. So we need to, when we do when we have review data, we need to put in things like, as I've already said, what type of review it was, but we also need to be very careful to put in things like our search criteria. What system did you use? And it's actually usually imperative, because most of our searches are done electronically online these days. It's imperative to say which system you used, but also to take screenshots, because systems change from day to day, and so you need to be able to demonstrate that you that is what you got on that day. You need to give dates, you need to give references and links. The screenshots don't usually have to go into your published data set, but you must have them in case anybody questions the way you got your data. You can see here in this one, we've put in all the search words and what was added and how we limited it, and what the date was when it was done. And then when you're making comparisons, you have to give the background to what you're comparing and why. You need to give both the original data and the calculations you've done to harmonize it. You may do comparative tables, and so on. And in your publication, you may have put a lot of that information in text, but in your data set, you can repeat that information, but in a more sort of stark form, with tables and showing how it all fits together. And quite often in your publication, you will put either the original data or the calculated harmonized data, and in your data set, you'll put both. So review data. Now what about images? What is the information that you need to put in to make images both compliant with general standards, academic standards, and to make them useful? First of all, compliance. If there's a person in your data, in your image, who is identifiable, you must have their permission to use the image, and you must say who they are. Otherwise, you must use an image in which the people are not identifiable, or in which there are no people. Then you must make sure you know who the image belongs to. If it's an image that was taken in the course of the work at SIBA. It usually belongs to SIBA. But you need to know who took it, who produced it, and give that person's name. So here you can see I've referenced SIBA as the holder of the copyright, and the photographer Candace Lowen, who took these photographs. And then you must make it usable by giving information about the image, about how it was created, what equipment was used, what software was used, and then about the image itself. Make sure you put in scale bars. So here's a picture of a series of Erlenmeyer flasks. Well, if you just had one of these, you wouldn't know how big it was unless you had included your scale bars. Put in annotations saying what everything is. Say what the picture overall is of, and what location it was taken in, what date it was taken, all sorts of information that makes the image usable. If you don't give that sort of information, somebody may not be able to actually follow what your image is really of. And then embedding your metadata. With images, especially photographs, you can put the data in a back file so that it's always attached to that image. And this is a quick explanation of how you do that. And you can look it up online. But you open up a box which looks like the one here, and you can put in things like its title, its what the subject is, who took it, what the date was, and often your phone will have put quite a lot of this information in, more technical information in to start with, but it's very helpful to go in and put in the other information. So it's always there. When someone downloads it, they've got the information. They haven't lost it because it was in the Excel spreadsheet and not with the actual image. And you can look on the on this file later, and there's some more sites that you can look at which help you to work out how to put the correct information with your photographs and other images. So today we well, in this video we looked at explanation data, at how to at the kind of data that you need to put in to make your data understandable. And the next video will be about location data, the kind of data that you're going to have to put with your data so that people can find what they want and find your data if that fits with the thing that they're doing. So just as I always like to acknowledge the UCT eResearch and Digital Library Services. When you ask me questions I can't answer, I often ask them. And of course, all the online courses that I've done over the years to try and get the lowdown on data sets.